Now we move further in this chapter of units and measurements, and let's understand dimensions. The definition of dimensions is dimensions of a physical quantity are the powers to which the base quantities are raised to represent that quantity. What are base quantities? We have done. So the base quantity is the mass, length, time, temperature, current, amount of substance, luminescence, right? These 7 quantities we have done. So the dimensions of a physical quantity are the powers to which the base quantities are raised to represent that quantity. Now let's take an example of force. Now force is what? Force is mass into acceleration. Mass, obviously that is the base quantity. Acceleration is, you know, it is distance by time square, more or less. If you don't go, that is acceleration dv by dt. Let's say simply we say that is acceleration is length upon time square. So mass I represent by capital M, length I represent by capital L, T, time as capital T. This goes over here, this is plus 2, and goes over here, this minus 2. So how do we say it? We say this is force is equal to the dimensional formula for this comes out to be like this. So force has 1. Over here we have say the power to which the base quantities are raised. So force has one dimension. Force has one dimension in mass. Force has one dimension in length. Force has minus 2 dimensions in time. Force has minus 2 dimensions in time. Similarly, if someone says pressure is what? Force upon area. Force is what? We have just done. Force is mass into acceleration upon area. Area is once again what? Length into length is equal to mass into acceleration is what? Length upon time square. You know, that is unit of acceleration in meter per second square. Meter per second square upon length square. Length into length. So this is mass into length upon length into time square. One length and one length get cancelled. So that comes out to be mass upon length into time square. Dimensional formula will come out to what? 1 upon L T2. This will come out to what? To M1 L. This will go up minus 1. T, it is in denominator T2. So when it goes over there, T minus 2. So pressure has, this is the formula, dimensional formula for pressure. So pressure has one dimension in mass. Pressure has minus 1 dimension in length. Pressure has minus 2 dimensions in time. Now what is the dimensional formula? The expression which shows how and which of the base quantities represent the dimensions of physical quantity is called dimensional formula of given physical quantity. Now let's write the dimensional formula for velocity or speed. Velocity or speed is what? Distance upon time. Distance is what? Length only. So it is length upon time. This is L1 upon T1. This goes as L1 T minus 1. Or a better representation is M0. There is no M. M0 L1 T minus 1. That is the dimension formula for velocity. Similarly, if we have to write the dimensional formula for acceleration, I say acceleration. Acceleration you can say, though acceleration is dv by dt, rate of change of velocity. Initial understanding, we can say now velocity is what, or we can write as velocity by time. Let's say velocity is what? Distance upon time. Velocity is distance upon time over time. So this comes out to be what? Acceleration comes out to be what? Comes out to be distance upon upon time square. Distance is what? L only. Time is what? T. So this is L1 T2. So this comes out to be L1. This goes up. T minus 2. So this is the dimension formula. We write the dimensional formula at least in terms of M, L, T and so on. So I have to write M also. Is there M in this? There is no M in this. So M0 L1 T minus 2 is the dimensional formula for acceleration. Dimensional formula for acceleration is M0 L1 T minus 2, or we can also say that acceleration has 0 dimensions in mass, acceleration has 1 dimension in length, and acceleration has minus 2 dimension in time. What is the dimensional equation? Dimensional equation is an equation obtained by equating a physical quantity with its dimensional formula is called dimensional equation. Like we know, that is velocity is distance upon time. Velocity is distance upon time. Distance is what? L1 T1. So dimensional formula for velocity, I write it like this in brackets, is equal to M0 L1 T minus 1. This whole thing is a dimensional equation. So obviously when you are saying equation, there has to be a sign of equality. So dimensional formula for velocity is M0 L1 T minus 1. In dimensional analysis, there are generally two kinds of questions which are being asked. One kind of a question is check. They'll use the word like check. The second is derive or deduce. When in the examination it is asked, that is check whether the formula, whether the equation or formula is dimensionally correct or not, then what you do is you find the dimensions of RHS, you find the dimensions of LHS. If RHS and LHS dimensions, they come out to be same, formula is dimensionally that is correct. If they don't, then obviously you can say this is not a correct formula. Like if there is a pendulum, I take a simple case of pendulum because that is generally given in the textbooks also. So the time period is given as 2 pi under root L by G. A is equal to 2 pi under root L by G. Now let's find out. This is obviously LHS. What are the dimensions? M0, L0, T1. Obviously that is the dimensional formula for this. What is the dimensional formula for RHS? This is RHS, this is LHS. Now come to this RHS, dimensional formula for RHS. This is 2 pi, it's a constant. We are not bothered about the constant. This is dimensional constant. This is length. Length is L. This is G. G is acceleration due to gravity. That is acceleration only. Acceleration is what? Length upon time square. You know it is meter per second square. Meter is unit of what? Length. Second is unit of time. So this it comes out to be L1 upon T2. So dimensional formula for G is equal to L1 T minus 2. That is the dimensional formula. So I write over here L1 T minus 2. So this is L1, L1 that gets cancelled, or otherwise what we can do is this is going to be root of L1. This goes up 1 minus 1 T. This is minus 2. When it goes up, it is plus 2. So this is 1 minus 1 0. So this is root of T square, which is what? It is T only. So RHS dimensional formula is what? T, or it is M0 L0 T1 is the dimensional formula for RHS. What is dimensional formula LHS? That comes out to be M0 L0 T1. So both the things RHS is equal to LHS. So that's why this formula is a correct formula. So formula is correct. Now let's once again check whether this formula, if I write a formula S is equal to UT plus half AT. We know the formula is half AT square. General formula is S is equal to UT plus half AT square. But I write S is equal to UT plus half AT. Using dimensional analysis method, I wish to find out whether this formula is correct or that is a wrong one. Here S you know that is distance, U is the velocity, A is acceleration and T is time. S is distance covered, U is initial velocity or velocity, you can say. A is acceleration and T is time. Now this is S distance, so it is M0. So S is distance, so it is M0 L1 T0. This is LHS. Dimensions of this and dimension of this, that should be same. in one physical quantity, you can add only the same physical quantity. You cannot mix, you cannot add or subtract two different physical quantities. Multiplication and division, you can do it. But that is, in one physical quantity, you can add only the same physical quantity. You cannot say 2 meter plus 3 liter is equal to 5 meter or liter. No. In meter, you are going to meter only. That is in terms of length. In length, you can only add length only. In length, you cannot add volume. Or from volume, you cannot subtract acceleration. Acceleration can be subtracted or added to acceleration only. Volume can be added to volume only, and so on. So over here, if this represents dimensions of length, it should also have dimensions of length, and it should also have dimensions of length only. Okay? So dimension of length over here, if I say u is what? Meter per second. Velocity. Velocity is what? Length upon time into time. Time cancel, so its dimension comes out to be length only. That is m0 L1 T0. So far, what is LHS? LHS m0 L1 T0. This is in RHS. This portion has m0 L1 T0. So far, the formula is correct. Now come to this. Half is a constant. We are not bothered. Acceleration is what? Length upon time square into time. So this comes out to be length upon time. So this is L1T minus 1. So now how comes out to be? Its dimension comes out to be L1. It comes out to be L1, whereas this is coming out to be L1T minus 1. So is it a correct formula? No, this is not correct formula. Why? Because if this is L, this should also be L, and this should also be L. We know that is right formula is S equal to ut plus half at square. Now let's check it up, whether this comes out to be correct or not. Now, when I say half at square, so it is half at square. Acceleration is length upon time square into, now what should I do? Time square. Now time square and time square that cancelled. This and this get cancelled. So this is length only. So this is length only, and this is L only. So that's why now it will be L only. Now this is L, this is L, this is L. Formula is